Three.
Good morning, everyone. Today we are going to see about a topic pipelining in ARM Cortex M0. So the introduction will be given by Sandeep.
Pipelining is a technique which speed up the processing by executing the instruction. There are three stages of pipelining: fetch, decode, and execution. It will be explained by Sudiksha.
So as Sandeep said, the first stage is fetch. Fetch is a stage where the instruction is fetched in pipelining, and the second stage is decode. It is a stage where the instruction does the operation by fetching the operands, and the third stage is execute, where the process is done in ALU. So in ARM Cortex M0, we don't have any storage specifically. So there are many bus as we see in last classes. So these buses will transfer the data.
Roleplay with three instructions. Okay. So when first instruction is entering the fetch stage, so instruction 1 enters the first stage. This is the case when there is no pipeline, right? Then instruction 1 enters the decode stage. After completion of the decode stage, instruction 1 enters the execute stage. So after execution, the results will be stored in the memory. Instruction 1 goes out. So it takes 3 clock cycles. Once after instruction 1 completes its task, instruction 2 enters, and then instruction 2 enters the decode. Instruction 2 enters the execute stage. So after the execution is completed, instruction 2 goes out, and then instruction 3 enters inside. Then instruction 3 enters the decode stage. Then instruction 3 enters the execute stage. So again instruction 3 takes 3 clock cycles. Okay, 3 clock cycles. So all together we can see instruction 1 takes 3 clock cycles, instruction 2 takes 3 clock cycles, and instruction 3 takes 3 clock cycles, assuming that every single instruction completes its task in 1 clock cycle. Okay. So all together without pipelining it takes 9 clock cycles. To complete 3 instructions it takes 9 clock cycles. Now let us see the case if there is a pipelining, how the process gets speeds up. Okay. Instruction 1 enters the fetch stage. So all these are resources: fetch, decode, and execute are resources. Instruction 1 enters the decode stage. Once after fetching it, instruction 1 enters the decode stage. When instruction 1 is in decode stage, instruction 2 enters the fetch stage. Right? Then instruction 1, after completion of decoding, it enters the execute stage. Then instruction 2 enters the decode stage. Instruction 3 enters the fetch, because the fetch resource is free. So instruction 3 enters the fetch stage. Now see, in third clock cycle instruction 1 is there. After completion of third clock cycle, instruction 1 goes out. So instruction 1 takes 3 clock cycle. See, when it goes out, instruction 2 enters the execute stage and completes it. So in the fourth clock cycle, instruction 2 completes the execution. Okay, so instruction 2 gets, so when instruction 2 is in execute, instruction 3 enters the decode. Then instruction 2 completes the execution stage in fourth clock cycle, and instruction 3 completes the execution in fifth clock cycle. Right? So see, the same 3 instructions are being performed when there is no pipelining. Instruction 1, 2, 3 for execution takes 9 clock cycle, and if there is a pipelining, how many clock cycles does the instruction take?
5 clock.
5 clock cycles, right? So see, with pipelining the speed has been increased, right? Altogether the processor efficiency will increase. This is the concept. So see, the resources are utilized effectively. Okay, so this is the concept of pipeline. Thank you.